Alright, so I haven't posted a video in a while. I think it's been about 6 weeks since I last posted a video. And the reason for that is because I've been working on a project. Now you've already seen the video thumbnail, so you already kind of know what it is. Basically, I've been working on creating a handheld device, a catapult that can be used to fire a fixed-wing drone straight into the air, meaning that you don't need to hand launch it. Now, this is a device that no one asked for, no one needs. It's not a device that's sort of essential by any means. But I just had this idea pop into my head, and I thought, do you know what? I quite like designing things, and I quite like 3D printing things, and it's just like a little bit fun and a little bit silly. So I thought, why not? Let's have a go at creating this device. So yeah, over the last 6 weeks, that's what I've been doing, and in today's video, I'm going to kind of talk to you about sort of the whole design process, how I got from sort of just having a concept in my head to having a final working device. I'll talk to you about some of the problems I encountered along the way, and then obviously at the end I'll show you the working device that I've actually come up with. So this project started with a doodle. I just had an idea in my head, kind of came to me out of nowhere, and I very quickly kind of jotted it down. And as you can see, it's basically like a sort of a handheld device that's got a couple of rails in it and a little carriage that slides up and down the rails with a hook on it. The hook will connect to a fixed-wing drone. And the propulsive force in this device is a couple of elastic bands. It's quite simple. And basically it works the same way as you can already go out and you can already buy catapults for firing fixed-wing drones, but they tend to be quite big devices that you put on the ground. Not very practical for sort of moving around easily, and I very much wanted to create a handheld device. Now, when I sort of conceived of this project, I also had a drone in mind. That would be my heewing H1. Heewing sent me a H1 months and months ago to do a review of, and I just didn't get around to it, so heewing, I apologise. But yeah, I sort of conceived that I would create a device specifically designed to fire the heewing H1. One, just because I wanted to do a video including the heewing H1, and two, because the heewing H1 is actually quite a small and lightweight aircraft, which means it shouldn't be sort of too hard to launch into the air. So the first thing I had to do with this project was buy some parts. So the first thing that I ordered was some steel rods. These were 8mm by 600mm steel rods. These are going to be the rods that the carriage moves up and down. I then bought some high tension sort of industrial elastic bands. That's also going to be the propulsive force in the catapult. And then also I bought some 3D printer filament. Now I did order some orange filament. The reason why I ordered orange is primarily because I was aware that, when I sort of create the final device, I don't want it to look too much like a real weapon, because otherwise some Karen's going to phone the police, and didn't want to deal with that. So I thought if I did it orange, nice bright colour, looks a bit like a toy, looks a bit like a water pistol or a bit like a Nerf gun. Hopefully that wouldn't offend anyone. And the second reason is orange is just because it's the colour theme of my YouTube channel, which is ironic because orange is my least favourite colour. But anyway, so obviously getting this project going, I had to start doing some designing. And the first thing I did was I just designed a very, very simple, very crude setup. I made a couple of basic little brackets just to hold the rails in place, hold the carriage in place, just so I could kind of just do a very brief test of proof of concept, see if it works. And yeah, as you can see, the proof of concept worked fine. I pull the carriage back along the rails, I let go of it, the elastic band pulls it back to the beginning, and it's working, exactly as you'd expect. Now, obviously, as you see here, this basic concept was clamped to a table. Obviously, whereas the final device needs to be something that I can sort of carry around. So the next step was then to sort of flesh out the design a little bit, add some sidewalls and a bit of a floor, make it a sort of a device you can actually pick up and hold in your hands. So that's what I did next. And as you can see, I sort of made the walls and the floor quite thick, because I was aware that obviously there's quite a lot of force in this, it needs to be sort of quite strong. And I also included a little hook in the ends just to attach the elastic band. Now the printer I've got is a Creality K1. The print bed on that is 220mm. Obviously this device is a lot bigger than 220mm, so I had to design the device to be in modules. And design it so that each of those modules could then clip together and be fixed together with some screws. Now, it took several hours to obviously sort of print this first prototype, and then as you can see here, I sort of tested it and it was working very well. Again, the carriage, I could pull it back, I could let go of it, and it would fly straight back down to the end and hit the end. And it seemed to have plenty of power to it. Now, obviously, when the sort of the final device is made, you need a way to kind of load the device and then also a way to fire it. So the next thing that I worked on was then coming up with a trigger mechanism. Now, I could have probably made this easier for myself and sort of gone ahead and sort of like looked up like trigger designs and stuff, but I wanted this to be a project that I entirely conceived myself. So I spent some time just in my head sort of thinking about how different trigger mechanisms could work. I designed a couple, and I designed a couple of like basic prototype mechanisms. I printed them, as you can see here, where I tested a few different designs to get like a proof of concept. But actually the design I went for is a little bit different. It's the one that you see here. And this is a design which uses 3 moving parts. So there's a trigger mechanism, which has a spring behind it. There's then like a little sort of like pinion that sort of moves up and down. And then that pushes on a little hinged arm that has a hook on it. And that little hook then grabs onto the carriage. Now the carriage has got like a little like sloped back on it. So as you pull the carriage back, the little sloped bit will push against the little hook. It will push the hook up, and then the hook will then drop back down and clamp onto the carriage. And then the hook is held in place with a elastic band, which is under tension. Now the way this works is obviously as you pull the trigger, as the trigger goes back, it pushes the pinion up, which then pushes the arm and the hook up, and that then releases the carriage. And as you can see in sort of these early tests, that worked pretty well. I was able to pull the carriage back and you'd hear it click as it locked into place. I could then let go of the device, carriage wouldn't move. I could then pull the trigger, hook would lift up, and then the carriage would fly back down, and it hit the end of the device. Now, it was at this point that I started to see some of sort of the early problems. One of those first problems was that I was seeing cracking in the end of the device in the plastic. Now, this isn't really all that surprising, firstly because PLA, which is what I was printing this device in, isn't the strongest material in the world. And secondly, in these early prototypes, I was not using a very high infill percentage. I think I was only using 15%, so there really wasn't very much material there in the end of the device. So yeah, now anyway, obviously having sort of this sort of working prototype, I can kind of see sort of like things were sort of starting to work. So before I sort of go ahead and sort of like work on my final design, I just wanted to do a little bit more testing. So what I then did was I modified the carriage so it had a bit of a hook kind of mechanism on it. And then I also designed a second sort of hook, 3D print hook, which then I installed on my plane, the heewing H1. And this would then allow me to attach the plane to the sort of the prototype catapult, and then allow me to then test firing it. Now, before I show you the footage of me testing it, I just want to explain that I chose to put the hook, obviously I had to choose somewhere on the plane to put the hook. And in my head, it made sense that the best place to put it would be directly on the bottom of the aircraft on the CG line, where the aircraft is most balanced. That possibly wasn't the best decision, which we'll talk about a little bit later. But obviously once I designed the hook and installed it in the aircraft, I was kind of committed to that. So that is what I did. Anyway, what we're now looking at here is some footage of me doing my first test at firing the prototype, and as you can see, it worked. When I pulled the carriage back, it locked into place. I was then able to load the aircraft on. I could then pull the trigger, at which point the mechanism would fire, and the aircraft was ejected from the end of the device. And as you can see, it actually sort of flew. It sort of travelled a couple of feet and sort of landed safely. Now, I should explain that at this point, the aircraft didn't have any electronics installed other than sort of the basic electronics. The aircraft was delivered to me as a P&P, so it had the motors and the servos, ESC installed, but it didn't have anything else in there. However, I did kind of make an estimate as to how much I thought the aircraft was likely to weigh when it was fully loaded. And I did just put a whole load of blue tack or mounting putty in there just to kind of simulate the weight so that the aircraft would sort of have an approximate correct mass, just so that I knew that when I was sort of firing the catapult, it was moving sort of a realistic representation of what the final aircraft would be like, if that makes sense. So anyway, at that point I had sort of a crude but working prototype, but there was still a lot to do. There's also a lot of problems to resolve. Obviously, I had that issue with the plastic in the front of the catapult was breaking. I was also finding that sort of the little hook that I'd put at the front for the elastic bands was actually getting in the way of the carriage sliding down, and the elastic bands are getting in the way. It just wasn't an optimal position to have that. Also, I just didn't really like the trigger mechanism I come up with. It was quite cumbersome, it was quite ugly, it was overcomplicated, so I wanted to fix that. And also, a much more crucial issue, and one which, as you'll see later on, took quite a long time to sort of troubleshoot, was the fact that when I was firing the catapult, what I was noticing was that as the aircraft started to move forwards and slide down the rails, also the tail was dramatically dropping down. It was actually smacking the back of the catapult housing. And after a couple of sort of like test fires of that, I was actually damaging the back of the aircraft. So that was another problem that I needed to solve. So anyway, what I then did was I went back to the drawing board and I basically designed a whole new catapult system. This took quite a lot of time to do, and basically I kind of modeled a lot of it in my head, kind of worked out what it should look like in my head, and then obviously sort of created the model in Fusion 360 to kind of work out sort of what it should look like and stuff. But a lot of the ideas I had, they were just concepts in my head. I hadn't actually tested them, so it was only once I actually sort of printed this new design I was actually able to sort of see whether any of the ideas I had actually worked. But in this this new sort of like second prototype, I changed various things. So for a start, there was a much nicer trigger mechanism. This was a much more simple trigger mechanism. So rather than having 3 parts, this essentially just had the one part. It had a single kind of trigger, which also acted as kind of the hook. Crucially, this hook mechanism now, rather than clamping the top of the carriage, it actually kind of clamped the bottom of the carriage. That just kept things simpler, made the design easier. Meant I didn't have the hook getting in the way of the latching mechanism for where the aircraft attached to the carriage. It was just a much simpler, much more elegant design for the trigger. I also designed it so that this new design, each of the modules, they had additional mounting holes so I could attach different things, because I was aware that as this design progressed, I'd want to be maybe making parts larger or adding parts to it, and rather than printing a whole new section each time, I could just print small sections and bolt them on. So that's why the modules had lots of little mounting holes. I changed this design, so rather than having the hook for the elastic bands in the middle, this now had 2 mounting points on the side, which kept them out of the way of the carriage. It also meant that there wasn't just one elastic band now, there was 2. My thinking there was it would have a more it would grab onto the carriage more evenly, rather than sort of having the force maybe being a little bit wonky, not quite pulling directly in the center. It was now pulling on both sides equally, so hopefully the carriage will slide down the rails a bit more linearly, a little bit more smoothly. I then redesigned the front end, so as you can see here, I made the walls at the end of the device thicker, and I also printed them with a much higher infill percentage just to make them stronger, so hopefully sort of prevent the problem with the plastic cracking. And one other thing I did as well is I left this little hole in the end of the device there. That's so that I could install a spring. This would then be so I could install a little shock absorber, hopefully to then kind of limit how hard that carriage hit the end of the device, again to hopefully try and stop the plastic from cracking. Now obviously with this new device all printed, I then went ahead and started testing it, and straight away I encountered a couple of problems. The first problem I encountered was that now I had 2 elastic bands on the carriage rather than 1. There was a lot more force pulling the carriage back down. It also meant I was finding it much harder to get the carriage to actually latch. When I was pulling the carriage back and it was engaging with the little hook on the trigger, I was finding that sometimes the trigger was able to hold the carriage in place, but other times it couldn't hold it in place and the carriage would just fly straight back down again as soon as I let go of it. Ow! Now this turned out to be for 2 reasons. The first reason was because the design of the catapult at this point, each of the modules was only held together with 2 screws, which were kind of acting like a hinge. And also I left a little bit too much of a tolerance between each of the parts, which basically meant that each of the modules was able to flex a little bit. And that meant that the entire catapult, it wasn't actually staying completely straight. It was kind of bending, it was bowing a little bit. And that meant that the trigger, the little hook on the trigger, wasn't fully catching the catapult properly. And that meant that with the force of the catapult pulling on it, combined with the fact that the entire assembly wasn't completely straight, meant that sometimes the trigger wasn't able to hold it and the carriage was able to slide back down. I did find that if I kind of held the catapult in my hands and kind of manually kind of straightened it out a little bit, the trigger could hold it better. But if I just held it kind of loosely and gravity was able to bend it, it couldn't hold it in place. I did manage to fix that. I'll talk about that in a moment. But the other thing that I found is that I made a little shock absorber in the end. I had a little spring there with a little plate so that as the carriage could go down there, I could hit the plate and compress the spring to hopefully absorb some of the impact. But actually what I found was that this device, even at this early point, I had so much force in it that after just firing it, I think it was like 2 or 3 times, that spring had actually got dramatically compressed. I think it sort of got compressed by, it lost about 1/3 of its original height because it got compressed that hard and that fast, it wasn't able to come back to shape. And obviously as soon as the spring lost its sort of springiness, it then just became pointless. It didn't really serve any purpose. Now, the springs I was using, they actually came from my old 3D printer, my Ender V3 printer that I had a couple of years ago. These were originally the bed springs on there, so possibly not the best springs to be using. I just used them because I happened to have them to hand. So realizing that those springs, weren't particularly good, I then replaced it with a stronger, much denser spring. And then I did some more testing with that, but I found the same problem. Even with those stiffer springs, after just firing the catapult a few times, those springs got dramatically compressed and then they stopped working. So I very quickly realized that, this little shock absorber using springs, it just wasn't really working very well. I could have maybe looked at adding more springs, so rather than just one taking the full force, I could have maybe had 2 or 3 or something, but I actually decided that there's probably a better way to go about this. So I ditched the idea of the shock absorber using springs. Now, as for the fact that, as I said a minute ago, the trigger mechanism wasn't able to hold the carriage properly sometimes, and the whole catapult was kind of bowing a little bit, I had a couple of ideas how to fix that. So the first thing that I did was I printed some additional brackets that I was able to then install on the catapult mechanism using the various holes that I left in place there, just to kind of stiffen up the design, to kind of hold it a little bit more straight so it couldn't bow so much. Adding these little brackets, they did help quite a lot, but it didn't solve the problem completely. So the other thing I did was I then went back to sort of the trigger mechanism. And when I first built this, there was a single elastic band inside holding the trigger mechanism down. So obviously as you pull it back and then let go, the elastic band kind of pulls it back to the default position. What I did was I added a second elastic band, meaning there's a lot more tension pulling down on the trigger. And that actually made a really big difference. It meant that as the carriage was pulling on the trigger mechanism, the trigger mechanism couldn't then move down because there's pretty much an equal force pulling down the trigger mechanism from the other side. So just adding another elastic band to the trigger mechanism, that made a big difference. Now after doing that, I tested the catapult a few more times, and yeah, it was working pretty well. However, I was still finding that I was getting a problem with cracking at the very front of the catapult. Crucially, I was noticing that the cracking was always happening in the same place. It was always happening on this corner here, right at the very, very end of the catapult in the first module. It was happening right there on the corner. And that got me thinking about something that I learned about commercial aviation many years ago, about the reason why it is that commercial aircraft have rounded windows and they don't have square. A lot of you guys will probably already know this, but for those of you that don't, basically, the reason why we have rounded windows on aircraft now, rather than square, which we used to have, way back when, is because whenever you've got metal and you've got a corner, like a sharp corner, that corner allows for fatigue cracking. It literally allows the metal to crack. And, a long, long time ago, like 70, 80 years ago, in the early days of aviation, there's actually a few plane crashes that happened because planes, the corner of the window, the metal there, it would crack. Eventually that crack would get so big that the entire fuselage would just burst open and the plane would fall apart. So a bit of material science kind of there, sort of realizing that, having sort of a corner was introducing a weak point to the material. What I then did was I thought, well, let's replace that corner with a nice curve and let's see whether that will eliminate the problem with the cracking. So basically I redesigned that front section there just with a little curve in it. I then printed another one of them. I then went ahead and tested this new design, and what I found is that it didn't solve the problem at all. I still found that I was getting cracking in that front part of the catapult design there. And actually, after testing the device, I think it was like 4, maybe 5 times, the entire front of the catapult, it just completely broke, completely shattered, and it flew off. And that's when I realized that, changing that one small thing wasn't going to be enough. So I then went away and I sort of thought about it for a bit, and I sort of started thinking more about sort of like shock absorbers, like how could I do that? How could I sort of like maybe put more springs in the shock absorber? How could I redesign this? Maybe even higher infill percentage to make the part stronger and stuff. But what I then realized was that actually it'd be so much easier if I just replaced the entire front section rather than have it printed in PLA, if I instead printed it in TPU. The reason for that is because TPU it's not a hard plastic, it's actually a rubbery plastic. It's quite sort of squishy and it's compressible and it's also stretchy. So yeah, that's what I did. I went ahead and I ordered a new roll of filament. This time it was a TPU one, still in orange, not quite as bright as the other orange, but still in orange. And then, yeah, I just reprinted the exact same part that I already had for the front there. I didn't change anything to the design other than the fact that I printed it in TPU. This took a very long time, I may add. I think it was like a 10-hour print or something, really long time, very frustrating. But yeah, once I printed that and I installed it on there, I was then able to fire the catapult design repeatedly, and it didn't have any cracking. The part didn't sort of suffer any damage whatsoever. It worked just by having it designed in TPU, printed in TPU. That worked as a shock absorber in itself, and that completely solved that problem. Now at this point, I was still struggling a little bit with the trigger mechanism not fully latching. It was certainly a lot better than it was before, but I was still finding that sometimes, you know, the trigger wasn't latching properly. It wasn't grabbing the carousel, and sometimes it would still, you know, slide off without me pulling the trigger. So then I started thinking, what else can I do to kind of like reinforce this trigger, make it work a bit better? Now, as I said, I already had 2 elastic bands in there. You know, I could have potentially added like a 3rd or even a 4th. But instead, what I decided to do was just to modify the trigger mechanism just a little bit. So in addition to having 2 elastic bands in there, I also had a spring. This spring went directly behind the trigger. And I used one of the sort of the stiffer springs. And once I did that, that completely solved the problem. You know, a combination of having the spring and the 2 elastic bands there, that made the trigger mechanism, you know, nice and stiff, and it meant that, you know, every time I then pulled the carriage back, the trigger was able to hold it in place perfectly, and it never slid off, you know, by itself again, which obviously was really good. Now, the next thing I wanted to solve was one of the problems I encountered with sort of the original V1 prototype. That was the fact that when I fired the catapult with the heewing H1 attached, I was noticing that as the aircraft started to move forwards, the tail of the aircraft was dropping down and it was smacking the back of the catapult. Now, at first, I wasn't really sure what was causing this problem. I looked at the catapult design in detail, and I did notice that the carriage there's quite a lot of slop in it. It wasn't sort of, maybe the tolerances weren't quite as good, so it wasn't gripping onto the rails quite as much as I'd like. So I did just slightly redesign the carriage. I made the holes just a little bit smaller so that it gripped onto the rails a little bit tighter. And this did take out quite a lot of the slop. I mean, the aircraft, you know, it physically couldn't sort of wobble quite as much as I'd like. But that still didn't solve the problem. You know, I was still finding that when I fired the catapult, the back of the plane was dropping down and it was hitting the back of the catapult housing. So the next thing I did was I then sort of, I modified the carriage again. I made it a little bit taller. My thinking there was I've made it taller, you know, that lift the tail up a little bit, so even if it did drop down, it still wouldn't hit the back of the catapult. Unfortunately, that didn't work. I found that, you know, the aircraft was still sort of rotating quite dramatically and the back was still hitting the back of the catapult. So the next thing that I did was I then started thinking like, well, what's causing the actual aircraft to rotate a lot? And at first I was thinking, well, maybe it's the airflow. You know, the front of the heewing H1, there's an opening there for the camera. There's also an air vent there. And I was thinking, well, maybe like the air is getting in there and it's kind of acting like a sail. It's pushing the nose up, which in turn is pushing the tail down. So what I then did was I just put a load of tape over the front of the nose just to seal up those holes. And I tested it to see whether that solved the problem. But as you probably guessed, no, it didn't. So then I really started thinking, well, what is it that's causing, you know, the tail of the plane to sort of drop down? And I'm sure some of you guys out there have already figured it out. I was probably being a little bit slow. But actually it was the G-force. You know, it's the G-force acceleration that was causing it to drop down. You know, if you're ever in a car and someone puts their foot down and, you know, the car rapidly accelerates, you get pushed back into your seat. Obviously, you know, we're all familiar with that. But if you think about, let's say that you had a bottle on a table and you put a lasso around it and the lasso is gripping the bottle at the bottom, and then you were to pull really hard on that lasso, the bottle would move towards you, but the bottom would move towards you faster and the top would move towards you slower, and the entire thing would rotate. You know, the top end would move down towards the ground. There's a rotational kind of action happening there with the G-force, because, you know, the point where you're pulling on the bottle is at the bottom. And basically, that's what I realized was happening with the heewing H1. Because the hook was kind of on the bottom of the aircraft, and the aircraft's a little bit taller, and also it's quite long, as the hook part was being pulled, the rest of the aircraft was kind of rotating around that point. It was acting like a fulcrum, and that's what was causing the bottom to kind of drop down. Now, realizing that was sort of helpful. It was like, at least I kind of identified, you know, what was causing it, but it then made it a little bit tricky to kind of sort of visualize, well, how could I solve that issue? So what I ended up doing was I designed a new module, which would clip onto the back of the existing catapult design. It would extend at the back a little bit, and I designed it so it had a couple of little little prongs on the back, little mini guide rails, just to hopefully hold the sort of the tail of the aircraft up, so that it physically couldn't rotate down as the aircraft fired. So I printed that and installed it on the back of the aircraft, and I did test it, and it didn't really work. I could sort of see that, like, in principle, maybe it was trying to work, but just the design was way too simple, way too crude. I did admittedly kind of rush it. So yeah, I kind of concluded that, like, I was probably going in the right direction, but I needed to do something a little bit more. So what I then ended up doing was I printed some these little sidewalls, like quite tall sidewalls that I put at the back. And the goal of these was that they would kind of, as the plane started moving forward, they would catch the edge of the fuselage, and they would stop the fuselage from sort of dropping. It would physically get in the way and it would hold the whole thing up. I printed a couple of these little sort of side walls, installed them on the back. I tested that, and then I could see that this was definitely having an effect. It was definitely helping. The tail was still dropping down, you know, quite a lot, but it was certainly helping the tail to stay up higher than, you know, it was before. So at that point, I realized that I was onto something, but I still wasn't fully there yet. So then I sort of started thinking, well, how can I sort of really solve this problem? And what I realized was I needed to extend those walls to go the entire length of the gun. And rather than try and sort of catch the fuselage, instead I designed them so that they very snugly fit underneath the wings of the aircraft. That meant that the aircraft literally couldn't rotate at all because they were very tightly kind of binding up against the wings. So I printed a load of these walls, I installed them along the entire length of the catapult design. And then, yeah, I went and tested it, and, you know, that basically solved the problem. You know, as you can see here, like, the aircraft barely rotated a wall because, you know, these walls were holding the aircraft up. So at that point, I knew that I was getting close to kind of solving all the issues that I had. I was getting close to sort of coming up with like a final sort of design. But obviously at this point, you know, this was like very much a mismatch of lots of different pieces. It was quite ugly, it wasn't great. So what I then went away and did, went back to Fusion 360, and I started a whole new design. I incorporated all of the little bits and pieces that I sort of learned from sort of the V2 prototype sort of along the way, sort of like taking various of the different aspects, kind of bolting them all together and making a much nicer, much more kind of streamlined design. And that's how I ended up with prototype 3. And as you can see, this design looks much cooler. You know, it's much closer to being sort of the final design. You know, as you saw in the thumbnail, this looks quite similar to what was in the thumbnail. This was a much better design. I put a lot more thought into it. I was much more sort of careful in designing things. Like, for example, I removed the tolerance between the modules. I made that smaller so they binded together a little bit tighter. And unlike in sort of the V2 version, there wasn't like a single mounting point on each module. There was now 2 on each side, so 4 in general. So there's no pivot point. Those modules were all held together much more tightly. They couldn't rotate or flex anywhere near as much as they could before. And crucially, you know, following on from the last thing I learned in the V2 design, this new design now had the sidewalls built in. Now on that V2 design, the top of the sidewalls was quite tall. I think it's about 5mm thick. That was introducing quite a lot of drag, and I can see that actually on the aircraft because it left some scratch marks in there. So on this new design, you know, I put like a taper on it, so that basically there's only 1mm of material on those guide rails actually in contact with the aircraft rather than 5. That just reduced a little bit of friction so that the aircraft can then slide down those guide rails a lot more smoothly. And yeah, as you can see, when I actually started testing this actually worked very well. You know, I was able to sort of like, you know, fire the catapult repeatedly. The aircraft was able to leave, you know, the catapult absolutely fine, sort of pretty much every single time. I definitely knew I was getting close to sort of coming up with a final design. There was, however, one problem. When I was firing the aircraft wasn't firing with as much force as it was in sort of the previous designs. That's probably because of the guide rails adding a little bit of friction. So yeah, when I was firing the catapult, the aircraft, it was leaving the catapult and it was getting airborne, but it wasn't firing as far as it was before. Now, wasn't super shocked by this, and basically the solution was to add 2 more elastic bands to the catapult. You know, up at this point I'd only been using 2, so at this point I added 2 more, so there's 4. I'd always had it in mind that I would be doing this, that I would be adding more elastic bands. So obviously I want this aircraft to fly off the end of the catapult as fast as possible. So yeah, that's what I did. I added 2 more elastic bands, meaning there was 4 pulling on the carriage. Now, this solved one problem, but it created another. Adding those extra elastic bands meant that the aircraft was able to fly off the end of the catapult with a lot more force. You know, it was able to get much more airborne, and you know, this looked a lot better. I felt much more confident about this. But the other problem was that meant that the carriage was then hitting the end of the catapult device with a lot more force. And what I found happened actually was it hit with so much force that it actually shattered the screws holding the first module to the second. Now, I should explain that up until this point, I'd been using nylon screws. The whole reason for that is just because I had a pack of M3 nylon screws like right here on my desk when I was designing this device. So I was like, well, I'll just use them. But it was at this point that I realized that using nylon screws wasn't going to be enough. I was going to have to upgrade them to metal screws. But I also realized that I was going to have to add a little bit more reinforcement to the catapult, because, you know, just having 4 points attaching the front module to the second module, it wasn't enough, and it meant that each of those points, each of those screws was being subjected to too much force. So the last thing that I needed to do to get this working was I had to just slightly redesign this V3 prototype so it has some reinforcement brackets running down the sides and also along the bottom, and then obviously replace all of those nylon screws with metal screws. So that is what I did. I had to then basically reprint the entire thing all over again. This took ages, took about 2 days to print all these parts, and that front part, that took 17.5 hours alone because it was TPU. Very frustrating having to wait that long for a single piece to print. But yeah, after 2 days, I then printed all of the parts. I'd also gone out and I bought some metal screws, so I then assembled the entire thing, put it all together, I then tested it, and that was the point when I realized that I had the device working. At that point, every single time I fired it, the aircraft was, you know, ejected from the end of the catapult flawlessly with plenty of power, and crucially, nothing was breaking. So that was the point where I realized that I basically had finalized the design. So the next thing to obviously, you know, see this project all the way through to the end was to then get the heewing H1 built and configured so I could then actually take it out and fly it. Now, getting the heewing H1 built wasn't too hard. However, I was very mindful that the heavier the aircraft was, the less kind of propulsive force the catapult would be able to exert on it, and therefore the aircraft would it wouldn't launch quite as well if the aircraft was too heavy. So when I was choosing parts for the heewing H1, I was very mindful to choose parts which were very, very lightweight. Crucially, the flight controller, I went for the smallest flight controller I could find. That was the SpeedyBee F405 Wing mini flight controller. That thing weighs something like 20 grams. Very, very small, lightweight flight controller. And then all the other parts as well, like I just went for the smallest like video transmitter I could find. I am using analog on this build. I could have used HD, but a HD setup would have weighed more. I wanted this to be really light, so I went for an analog setup, and the lightest analog FPV video transmitter I could find in stock was the SpeedyBee TX 800. I can't remember how much that weighed, but it really wasn't very much. That was like 10, 15 grams or something. Analog FPV camera. I put the Walksnail GPS in the aircraft just because that's very small and light, and I know it's reliable. And I used an ELRS receiver, which basically weighs nothing. Tried to be very mindful of keeping sort of the wiring sort of as short as I could, just to save those few extra grams there. And then for a battery, I used this 1100 2S LiPo battery. This aircraft is only designed to run on 2S. When Heewing sent it to me, they did send it to me with a battery, but that was only a 600 milliamp 2S LiPo battery, which I thought was just a little bit too small. I wanted to get a bit more flight time in it, so I went and bought this 1100 milliamp battery. And yeah, the total weight of this build after I installed all of the electronics was 307 grams. And I think that's pretty good because, you know, the aircraft, when it arrived to me in its stock configuration, was 197 grams. So I'd only added 110 grams in terms of electronics and also battery. And yeah, once I'd installed all of the electronics into the aircraft, I then had to go ahead and do the programming. And most of this is completely straightforward, just INAV programming. However, one very key step to this, and this was part of my kind of the original vision for this project, was the fact that the aircraft needed to have nav launch enabled, or launch mode. For those of you that don't know, launch mode is basically a mode that you can put onto your aircraft so that when you throw it, it detects that it's been launched, and then it will spool up the motors, and it'll adjust its own altitude, and it should climb out by itself. Obviously, having that system set up in the aircraft is kind of vital, because when I fire the catapult and the drone gets into the air, I can't also be holding the radio and sort of controlling the sticks and stuff. I needed the aircraft to leave the catapult and take off into the air by itself. So yeah, I had to set up nav launch mode on the aircraft. I had done it before in the past, but I did just watch a modern tutorial, just because obviously a few things are changed in there. And the tutorial I watched, the guy was showing how he set it up for a heewing H1. Obviously, sorry, a heewing T1. Obviously, I was building a heewing H1 here. Similar sort of size aircraft, a little bit lighter but similar. But I just copied all of his settings, put them into INAV. And then, yeah, I went and did my first test. This was just an indoor test. I didn't have the props attached to the aircraft, but I did power the aircraft up, installed it onto the catapult, enabled nav launch mode, and then fired the catapult. And yeah, the goal was that, if this was working successfully, as soon as the aircraft left the catapult, the motor should fire up. And yeah, true enough, that is exactly what happened. Fired the catapult, and before the aircraft had even left the end of the catapult, I could hear those motors fire up. It glided across the room, and obviously when it landed on my sofa, I could hear the motors running. That's when I knew that this project was basically going to work. So that brings me obviously to the bit that you're most interested in seeing. This is me actually, using the catapult properly, me actually going outside and actually testing it to prove that it worked. And that's what I did on the very next day. I went out to sort of one of my local flying fields, obviously installed the props onto the aircraft. And yeah, I installed the aircraft onto the catapult. Obviously I cocked it back first, installed the aircraft onto the catapult. Then on my radio, what I needed to do is I needed a flicker switch to enable nav mode. You then arm the aircraft, you put the throttle up. I think I put it up to about 80%. I think there's then about a 5-second countdown. The aircraft beeps as it's doing that, after which time the motor starts spinning very slowly. They're only spinning at 20%. I then aimed the catapult up towards the air, and then when I was ready, I pulled the trigger. The aircraft was launched off of the catapult into the air, and straight away those motors fired up and the aircraft soared straight up into the air. And I'll tell you what, I was just ecstatic to see that. Obviously I was worried that something was going to go wrong, maybe it wouldn't work. I was expecting that maybe I might have to do some programming changes, might have to tweak it a little bit to get it to work. But no, it worked absolutely perfectly, and the aircraft just went straight up into the air with no problem. Now, obviously I wanted to know that wasn't just a fluke, so I did do a couple of other launches with the catapult, and again, every single one of them worked absolutely fine. Every time I fired it, the aircraft went straight up, which was fantastic. However, I did encounter one minor issue on one of the launches. Basically, when you program the nav launch settings, there's a whole load of different settings that you can program in, and one of them is the target altitude, the altitude at which you want the aircraft to climb up to before nav launch cancels. I think the initial settings I put in was 50 meters or something. It's not all that high. And basically on one of the tests I did, after I fired the aircraft into the sky, on that occasion I was also filming my GoPro. So after I fired the aircraft into the sky, I put the catapult down on the ground. I then turned my GoPro off before I then picked up my radio and put my goggles on. And as I did that, literally in that moment, I realized that the aircraft was about to hit a load of trees. I was very lucky that I was able to pull back on the stick just in time and get the aircraft to climb out of the way and not hit the trees. But yeah, that was a real hair-raising moment, and that's when I realized I needed to just make a very few small changes to the programming. So that's what I did. I went back that night. I just changed the settings a little bit just so that the angle the aircraft climbs out at is a little bit steeper, and it aims for a higher target altitude. And then, yeah, on the next day, I went out and I did a load more testing. And I will show you the footage from those other tests that I did in a moment. All of them were flawless. We ended up doing sort of a couple of trick shots as well, which hopefully you'll enjoy watching. But yeah, I just thought I'd conclude the video first and just say that, you know, this was actually a really fun project. You know, as I said at the beginning, like I really enjoy designing things. I enjoy 3D printing. I like just kind of doing like silly things. This catapult thing is completely pointless. Like no one needs this. The Heewing H1 is an incredibly easy aircraft to launch. You don't need a catapult to do it. However, it's fun. And you know, you get to launch your aircraft with a little bit of style, a little bit of a flair to it as you do it. So yeah, if anyone's interested in sort of making one of these for themselves, I will at some point put the design files online so anyone can sort of 3D print their own. And I think the whole project probably costs about sort of 20 quid, maybe 30 quid at most. It wasn't an expensive project. But yeah, this is what I've been doing for the last 6 weeks. I have been building the drone slinger catapult for firing a Heewing H1. Should also mention as well, just before I end, that this catapult is very specifically designed for a Heewing H1. However, it wouldn't be hard to modify this for other aircraft. If you wanted to make one of these for a Heewing T1, for example, all you'd need to do is just widen the catapult design by about 1 centimeter, I think, and then a Heewing T1 would fit on that. And I'm sure it can be modified to fit a whole load of different aircraft as well, as long as they're dual tractor aircraft. Whether it work with a wing is something I need to look at in, you know, at some point in the future. But yeah, anyway, that's enough of me talking. I've been talking for a very long time now, but I hope you have enjoyed sort of watching this video. I hope you've enjoyed this project, even though it is a little bit silly. And I will leave you with some footage from sort of the additional sort of like launches that I did with the drone slinger. And yeah, if you enjoyed watching this video, please do give it a like down below to keep the YouTube algorithm happy. And yeah, I guess I'll catch you in the next one. Cheers, guys. Bye.
Quentin.